Hello everyone. Today we'll discuss divide and conquer technique. So this divide and conquer algorithm, it's a technique which is used to solve a larger problem. If a larger problem is given, instead of start solving it as such, the easier way is we have to make that large problem into smaller problems. Then we can handle it easily. So that is the approach we are going to follow in divide and conquer. So we are going to deal with the larger problem here. So we have to break the problem into smaller subproblems. We are going to divide the larger problem into smaller subproblems. Then solving the subproblem. We are going to divide the problem into smaller subproblems. Then solve the subproblems. Then combine it. Okay, so this is called divide and conquer. We are going to divide the problem and we are going to solve that subproblem. Then you are going to combine all the solved subproblems. So this is the technique we are going to follow. So this is the algorithm for divide and conquer. So how it works? So these are all the steps involved: divide, conquer and combine. Divide the given problem into subproblems using recursion. Here we are going to use the technique called recursion. Okay, because we are going to perform operations repeatedly. So we need to use recursion here. The first step is dividing the problem into subproblems, then conquer. That means solving the subproblem recursively. If the problem is small enough, then solve it directly. Okay, then combine. You have to combine all the solved subproblems, merging. You are going to merge it. So these three steps are important: divide, conquer and combine. Let's solve an example for divide and conquer technique. So this is a merge sort. Okay, this is merge sort technique. So we are going to apply this divide and conquer algorithm. Just remember the steps: divide, conquer and combine. So this is our given array. We are going to sort this given array with the help of divide and conquer. So here I am going to use the merge sort technique. What is the first step? We have to divide the array into smaller arrays. Correct? We have to divide it. So this is my full larger array. How can I divide this array? I have to divide this array into equal halves. So when I say equal halves, we must we must know the we must find the midpoint of the array. Okay, mid position of the array. How will you find the mid position? So array starts from 0, 1, 2, 3, 4 and 5. Correct? So how will you find the mid position? Mid position is low value, first value plus last value divided by 2. Okay, first index, last index divided by 2. So my last index is what? Is 5. First index is 0, my last index is 5. So 0 plus 5 is 5. 5 by 2 is what? 2.5, but we are going to have only the integer part. Okay, so that I can take 2 only, not 0.5, only 2. Whole number is taken 2. So my mid value is what? 2 here. So which means 2. So till 2 I am going to split the array. So how can I split? How can I split? 7, 6, 1. I can split my array as 7, 6, 1. 0, 1, 2. I have found the mid value. Mid value is nothing but 2. So till 2 is my first array. So after that is second array. Mid plus 1. From mid plus 1 to high is my second array. That is right array. So this way the merge happens. Okay, 0, 1, 2, and the next part 5, 4, 3. So here 5, 7, 6, 1 and 5, 4, 3. So next is what I'm going to do. I'm going to further divide this 5, 6, 1 into subarrays. So how can I do 0, 1, 2? Okay. So again I have to find the mid value. What is the low value? 0. High value is 2. Divided by 2 is what? 2 divided by 2 is 1. Correct? So from till 1 I can say this is my left array. Okay, till 1 I can say this is left array. So 7 and 6 I'm going to have in a separate array, and only one element left. So that is I'm going to have this as in second array, right array. Okay, again I'm going to split this 7 and 6 further. So 0 and 1. So 0 plus 1 is what? 1. 1 by 2 is 0.5, 0.5, but I have to take only the whole number, not the decimal value. So only 0. So 0, the 0th position, 7 only here, 7 only there. So 7 I am placing here and 6 I am going to place here. Okay. So this is how my divide function calls, and always I'm going to divide it. Recursively I'm doing it. Just consider what I'm doing. I'm having a full array, full length array, full large array. I'm going to divide this array into, each step I'm going to divide this array into 2, n by 2, and this is n by 4. So something like that I'm going to divide this array. Repeatedly I'm doing this process. So I can use recursion. So this is a recursive function. Okay, I'm using recursion here. So when I say recursion, we should have the base condition, right? So where I have to stop this recursion, where I have to stop this divide step. So here in this case, I have to stop this divide array, dividing step when I reach the single elements. When I have single elements, I have to stop the division or dividing part. So here 7 is a single element, 6 is a single element, so 5 is a single element, 4 is a single element. I cannot divide the single independent, that is 7 into again 7 into 2 or 3 or whatever may be. Okay, because it is only one element. So I cannot split this element into further. So at that at this time I'm going to stop my division part. Okay, so this is my divide. So we'll see the next merging part in the next video.